We're going to take a look at something called piecewise functions, which is something you've probably never heard of before in your math life, but you will hear about in future math classes. Since it's something you don't know about, let's ease into it by starting with something you do know about, which is graphing both of those lines on this coordinate grid. And lucky for us, both of those lines are in y-intercept or slope-intercept form, so we know the y-intercept and the slope, and we can just go ahead and graph those. For the red line, I put up a y-intercept of 3, and I count my slope of negative 1/3, which is rise of negative 1, run of positive 3, rise of negative 1, run of positive 3, or if you're crazy, rise of positive 1, run of negative 3. Either way, you end up with that line, and I'm going to pause this and graph the other one as well. Okay, no big deal. I just graphed those lines, but now we're going to take a look at how doing something as simple as that can help you with piecewise functions. So over here on the right, I revealed a piecewise function problem, and you'll notice first of all that it has symbolism that makes you go, ah! Most people don't like that symbolism, but what we're saying here is our new graph is going to be partly made up of this red graph, and our new graph is going to be partly made up of the purple graph. So the reason they call them a piecewise function is I have two pieces that are going to make up one graph. So over here, you will always see the equation that you're supposed to use, and over here you will always see the domain that you're supposed to use for that equation. So for example, the graph that I draw is going to be this red graph for all x values less than or equal to 3. Once I get to x equals 3, I'm going to switch over and I'm going to graph this purple graph for all x values greater than 3. So if my domain is concerned with x equals 3, I'm going to find x equals 3 on this graph and put a mark there. At x equals 3, I'm going to do the switch over. Now anything less than x equals 3, I need to do that graph right there. Well, I've already graphed this graph over here, so I'm not going to redo that thinking. Basically, I'm going to ride this graph the whole way until it gets to x equals 3. I can't continue on further because that's going for x values greater than 3. For example, that's x equals 4, x equals 5, x equals 6. So I'm just going to recreate this part of the graph over here. So notice now that I have this red graph and it's living its life in all x values that are less than or equal to 3. It doesn't go to the other side. Now we have to go switch to the purple graph, which we've already done over here, and we're only allowed to graph it for x greater than or equal to 3. So if I think about how I graphed this before, all of these parts right here are x values that are smaller than 3, but as soon as I get here and start crossing over to this side, my x values are now bigger than 3. Here's an x value of 4, here's an x value of 5. Be careful not to let your brain mix it up with y values. So now I'm just going to continue on and I'm going to recreate that graph. And it would look something like this. This would be my final product. I now have the piecewise function that is partly the red graph, partly the purple graph, and the parts that I'm choosing to graph correspond to the domain. So that gets a little complicated, so if that's bending your brain, here's what I suggest. Take your two graphs and graph them fully on a coordinate grid. And then, after you've graphed them fully on a coordinate grid, hopefully you're using pencil, erase the parts that are not in play. So for example, if I graph that whole graph on my coordinate grid, I don't care about any x values that get bigger than 3, so I would take my handy dandy eraser, in your case, I used pen so you could see different colors of graphs, and erase the graph that the part that you don't want. Same thing with the other one. Graph that whole thing, but only allow the x greater than or equal to 3 part to be seen, so that's all parts of the graph bigger than that x equals 3. So you take your handy dandy eraser and erase the parts where x is less than 3. And by doing it that way, you also come up with the same piecewise function that I did here. So you got a couple of options for how you might want to graph that. Okay, we're on to another example, and the real example we'd be working with would be this one over here, the piecewise function, because f of x has one piece and another piece. And some of you might be able to go straight from here to the graph, but if you're having trouble with that, graph the whole thing first and then erase the parts that you don't need. So I'll graph the whole thing over here using this coordinate grid, and then we'll take away the parts that we don't need. I look at the red piece, and the y-intercept is 1, and the slope was not written, but it's a 1 over a 1. So that means rise 1, run 1. We're going to follow this pattern. On the purple one, the y-intercept is positive 2, so that's over here. And the slope is negative 3/2. That means rise of negative 3, run of 2. Rise of negative 3, run of 2. Or rise of positive 3, run of negative 2. And now I've got that graph. And I just made a mistake. Oh, no, I didn't. My y-intercept is 2. Okay, so I'll stick with that. Now if I want to make my real graph, basically for x greater than negative 2, so there's negative 2, I need to include the red graph. Well, the red graph, and by the way, here's negative 2 on that graph, would start out right down there, and I'm going to use an open circle. The reason I use an open circle is it says x is greater than negative 2. I'm not going to include it with a closed circle. Now I'm going to go to the purple one, and for x less than or equal to negative 2, so all values over here, I'm going to draw the purple one. Well, boy, the purple one is way up here at negative 2. It's way up there. I'm going to use a closed circle because it's less than or equal to negative 2, so it's going to include it. And without being precise, I'm going to draw that graph. So now this one looks quite a bit clunkier, but this piecewise function is that, and the red piece is all pieces where the x values are greater than negative 2. The purple piece is all pieces where the x value is less than or equal to negative 2. Like I showed you before, if you didn't like that, doing this method over here, you just graph both of them fully and then shade or erase away all your x values less than negative 2 for your red, and for your y, or your purple one, it has to live less than or equal to negative 2, which would mean we do a lot of erasing of all this purple. But by doing that thoughtfully, you now have the red one living in the domain that it's supposed to live, and the purple one living in the domain that it's supposed to live. All right, for this very last problem, we're going to go straight to the piecewise function. I see the domain splits at 1, so that's the spot on the x-axis that I have to pay close attention to. And I purposely chose two graphs that are actually so simple that you might actually have problems with them. Now remember, this is y equals, so I could say it's the line y equals 4, and it's the line equals negative 1/2 x. So the reason these are so easy they're difficult, this one doesn't have a y-intercept, so you might think about plus 0. This one doesn't have anything, doesn't have an x variable for a slope or a y-intercept, because you're supposed to hopefully memorize that this is a horizontal line. Pretend that that thing was a, oops, this is a horizontal line, pretend that was a z. All right, so let's graph this. I'm going to start with the purple one. It's a horizontal line, y equals 4, and it should be for x's greater than 1. So I'm not going to include the 4, just all x values greater than 4. If I'm just graphing y equals 4, it's this entire line, but I only care about the x values greater than 1. Now I take a look at this, negative 1/2 x plus 0. That means my y-intercept would be 0. And the slope is down 1 over 2, down 1 over 2, down 1 over 2, or up 1, negative 2, up 1, negative 2. Now this can only be allowed to happen for x values less than or equal to 1. So if I follow that trend, it would end up looking like that. So this is my piecewise function that matches that. Daydream about doing the entire graph, but only using the part that the domain calls for. All right, that's something brand new, piecewise function. I'm sure you'll enjoy it.